There we go. We had a hypothesis about Max. Now this has been a week. You guys have had a lot of snow between then and now. So you may have forgotten what our hypothesis was.
And Project 3.
And Project 3. It's a damn good one. It's a damn good project. Michelle, I love what you posted. Dude. I don't even know what I don't know. That's, you don't...
Tap it out. It's time to
No, You got, you
so
totally got it.
today, are you going to explain the exclamation?
I think the project does a pretty good job of explaining it.
Yeah. Except that I found the explanation.
Now remember, somebody, Elizabeth in the other class made a little study group.
Yeah, for tomorrow.
Good! And you can always email me.
There's something.
Email back. Just remember that.
Sean, I found the exclamation in a different spot where you had indicated. At least that's how I...
Oh, you went a different way. You went left instead of right or right instead of left.
I went right.
That's okay. That just goes around the corner. That's like getting back to your house around the block going left versus right. You can there.
Because you had the symbol of the arrow pointing this way, and I thought you meant like scrolling down to 4, but I had to go...
right. And then down. Yeah, there's multiple ways to get to it. You can always just, yeah, so that's good, whatever works for you.
I found it so...
Anyway!
We had a hypothesis about Max.
Say that again. Yes, Max, hypothesis. What was the hypothesis? Sandy, please.
Does he know that he's putting his shoes on the wrong feet, or is he doing it on purpose?
Okay, so, or, actually those are the same thing, right?
Is he guessing?
Yes.
Is he guessing, or does he know what he's doing? Okay, so that's the question. Is he guessing when he puts his Crocs on, or does he know, quote unquote, that that's what they should look like? So that is the hypothesis. Which, actually, that's two hypotheses. Number one, he's guessing. He's just walking out, and you know what? Having a 7-year-old in the house, for the past 3 weeks, and I asked Jen about this, she's like, I know, we find one sneaker in the middle of the living room. And the other one is either in his room, it's in the garage, it's in the bathroom. I found it in the cat litter once. So, honestly, it could be that he just walks down and grabs a shoe and throws it on his left foot. Whatever shoe he experiences first goes on his left foot. Which means, depending on the randomness of the shoe in front of him, he might randomly get his shoes on, or he might always get his shoes on the right or wrong feet. So it's hard to know. But it's not hard to know what would be happening if he were guessing. It would not be hard to model if he were guessing. That's what your TI will help us do. So we had a request for disc fill. We're using disc fill again today. Let's talk about what it would mean for Max to guess. Let's talk about what it would mean if Max were guessing. If he were guessing. Now let's see if we can understand why this was a binomial experiment. Say that again. Either he is or he isn't. That's okay. Please interrupt. That's beautiful. He either is or isn't guessing. That makes it binomial. Two outcomes. Two outcomes. Beautiful. Do you remember this? How many times did I observe him that summer? Good, you remember. I watched him, I set out in June, I said I'm going to watch him 10 times. I didn't say I'm going to watch him all summer or all days. I said I'm going to pick 10 random days, and because I'm a geek, I went inside, I used the TI to generate 10 dates, and I put them on the calendar. And I remember to do it with the help of technology to actually check him each day. Each day. So I had a fixed number of trials. So I've got 2 outcomes, check. Excellent, we got sugar floating around, this is beautiful. Fixed number of trials, 2 outcomes. Say that again, Alicia?
I said it should be coffee.
Yes.
It should be coffee, sorry.
Coffee, yeah.
I shouldn't look it up on the blank. That's a little harder, 8 pounds a gallon.
No, it's not. You can do it.
So, what's the only other thing we have to make sure it is to make it binomial? This, we got that. It is or isn't? You got it, Scotty. You got it. It's tricky. It's tricky. I'm going to call it the Corey condition, because you nailed it last week. I remember this. I'm very proud of you. The Corey condition is that the 2 outcomes have to be, or trial to trial, have to be what? Very nice. They have to be independent of each other. In other words, you can't carry forth knowledge from one trial into the other. So in other words, if he guesses on this trial, that result can't affect how he acts the next time, which can't affect how he acts the next time. I love that. Yes, it has to be a purely random assignation, not deterministic. That's why I couldn't let him watch me. Excuse me, I couldn't let him watch me watch him. Because if he saw, sorry, that was a little bit meta. If he could tell that I was watching him, he's going to act differently. Which means the trials wouldn't be independent anymore, right? Maybe in the first one or second one were, but then it's like, why does Dad have his notepad out? He puts his glasses on when he watches me, put my shoes on, and then he's going to start acting differently. As soon as you observe an object, it starts acting differently. Quantum physicists figured that out a long time ago. So, you have to make sure you've got independent trials. And I'm going to put a checkbox on that. That, in my opinion, is the hardest thing for researchers to guarantee. The fact that the trials are independent, that one trial is not impacting the next trial. It's so hard. That's why there are research methods classes. Some of you have to take, some of you have taken them, some of you will take them, for setting up the design of an experiment. Once you have the independent trials, for example, if you do the Sarah Palin quiz this time around, if you do the Sarah Palin quiz, I'm assuming that she's guessing. Just, the Sarah Palin quiz is the same as the Max Crocs quiz, except she has more trials than he does. She has 32, I think, or 33, and he only has 10. But if I'm assuming she's guessing, that means she's purely guessing. She has a little magic 8-ball picking her predictions for her, right? Which is purely random, right? Purely random. You shake it, comes to the top. You shake it again, the ball forgets what it showed you the first time, it just showed you something else. 105, we just got done the whole week and a half on randomness. And they're getting it now. They're getting the fact that it can clump, that it can actually have these clumps that happen. Because just because you roll a 1 on a die doesn't mean you can't roll a 1 next.
Right, it doesn't remove it.
It doesn't remove it from the random assignation of the roll. So just because Max puts his Crocs on these 2 feet this time, he doesn't remember that when he puts them on the next time. That's what guessing means. Guessing means he just has a shoe as a foot. He grabs whatever shoe is randomly in front of him and throws it on a foot randomly. So, I think we have, not only do we have 2 outcomes, because so far, this is the same as buying chickens. 10 chickens. If we were to buy 10 chickens, independent trials, 2 outcomes. But this is different than the chickens, isn't it? Isn't this different than the chickens? In what way? What? You guys.
With the chickens, there was a 90% chance there was a female and a 10% chance.
Yes, ma'am. How's this different?
Really?
If he's guessing, you have it.
It isn't.
So it's
50.
boom! You knew it. Yes. You have the hardest part. With the chickens, it's 90-10. Lots of things are binomial, but they're not always 50-50. For example, will I die riding my bike home today?
Maybe.
Maybe. It's 50-50 because I either will or I won't, right?
No.
No, it's not 50-50. It's something very large, something very small based on past data, even in the snow. So there are 2 outcomes, like Taryn said, but for Max, the guessing part makes it a 50% chance that he gets the shoes on the correct feet. That's what makes it different than the chickens. The chickens are 90-10, Max is 50-50. The chickens would be 50-50 if I bought them from a non-sexed operation. The reason it's 90-10 is because they're sexed. But did I tell you the story about Jen wanted to buy one of the chickens from the school? Did I tell you this? We lost a bunch of girls this year due to disease and also due to a murder, which is terrible. But damn chickens kill each other. Do you believe that? Oh, chickens kill each other. It's crazy. It's crazy. So we were going to get more. And Jen's like, let's just buy them from the school, because the school had one of those 4-H programs where they raise the eggs and they hatch. I was like, babe, no. And she's like, why? Because she wanted to buy 4 from them. And I said, if we buy 4 chickens from them, right? That's about they're not sexed. That means I got a 6% chance, and only a 6% chance that they're all hens. Now consider that difference, right? If you buy 4 chickens from an unsexed operation, the chance of them all being girls is 1 in 16. Think about why. Think about why. It's 1 in 16. Because you have to get the first one to be a girl. What's the chance of that happening? 0.5. Half. Then the next one has to be a girl. What's the chance? 1/2. Now it's down to 1/4. 1/2 times a half. Then buy another one. What's the chance she's a girl? 1/2. Now you're down to 1/8. And the 4th bird comes out. What's the chance she's a girl? 1/2. Now you're down to a 16th. The 16th is about 6%. That means there's a 94% chance you got at least one rooster in that 4. I do not like those odds, right? I do not like those odds. That's why I want them sexed. It becomes a Bell distribution and not a skewed distribution. I don't want a Bell distribution if I'm picking the sexes of my chickens, right? I don't want a Bell shape. A Bell shape means I've got half boys, half girls. I do not want half boys, half girls. I want as many girls as I possibly can have. So I want it skewed. I don't want it balanced, I want it skewed. Does that make sense? Hopefully that makes sense. If it doesn't, we'll do a couple graphs and disc filters to kind of demonstrate that for you. Please, Scotty.
This doesn't really demonstrate the male zygote not being...
No, you're overthinking this, brother. We're thinking just simply male or female, right? Male or female, not looking biological, just what the rancher told me in the store. That's cool. And it's related, but not the exact same. It's a more simplified version. Good so far? Okay. So now the question is, if we know all of this, can we build the distribution that describes the number of times Max gets his shoes on the correct feet? And we sure can. Grab your TIs. Let's do it. We all, please. I thought I heard my name. Maybe I didn't. Oh, you shall we? I thought I heard Sean. Yes. Yes, we shall. There it is.